And hello, everybody. It's 10 o'clock where I live. It is probably something different where you live. This is Nick McPhee. This is Unhindered by Coding. Hello, Izitsu. Wonderful to see you, as always. Be here for 2 hours doing stuff with evolutionary computation. Not entirely sure what. But so one option is to continue to work on the READMEs. And that's, I think, probably the more important, in some sense, thing to do. But I'm actually, especially since I think Justus might not be here until a little later, there's another issue I just there is an issue that had been niggling at me because I thought it was I felt like there was something we needed to do, and I just never got around to looking. Well, I finally looked, and yes, indeed, there is a thing that we probably ought to do. And actually, I don't know. I didn't actually check if there is an issue for this. UMAD. Yeah, there we go. So I think, yeah. So this is the thing. So actually, I had even documented it. Well, yay me. So the main thing is, if we look at the UMAD paper. Oh, actually, I should probably back up a second and remind everybody what UMAD does. So UMAD is a mutation operator. It takes a linear genome, and it stands for and a not fixed length linear genome. So we're allowing the genome's length to grow and shrink, which would be true, for example, in evolving programs where the number of plushy genomes is allowed to shrink and grow. But also it would apply to other kinds of linear genetic programming where the size of the program can grow and shrink over time. So in UMAD, we have uniform mutation by addition and deletion, as it says here at the top. And this is from the paper that introduced UMAD a decade ago. Let's see. This was published in 2018, not quite a decade ago. The paper is Program Synthesis Using Uniform Mutation by Addition and Deletion. And the key idea is you have your genome, and you go through and you make a set of additions. So you randomly add some genomes over time. Not over time. You go through the genome. I'm not saying this very clearly. You go through the genome. At each point, you make a decision whether to randomly insert a new random gene. So you flip a coin to decide, do you put a gene in there? And the likelihood of adding a gene is this addition rate. And if you decide to add a gene, then you choose one at random in whatever makes sense in your universe, and you insert one there. And you move to the next position between two genes, decide whether to put one in. Next position to the end. Then you pass through and you do deletion. So for every gene, you decide, do you remove that gene randomly? And that, how likely you are to remove a gene is this deletion rate. And there's some math here, and it's repeated in the this document. The math says that if you set your deletion rate to be the addition rate divided by 1 plus the addition rate, then you're guaranteed on average to have the same length that you had at the beginning. So if you set your addition rate really high, your deletion rate to say 0, then your genomes will just grow and grow and grow and grow. And if you set your deletion rate really high and your addition rate, again, maybe to 0 in an extreme case, then your genomes will shrink until you eventually have nothing, which is not so helpful. And it turns out that some simple math says that if the deletion rate is the addition rate over 1 plus the addition rate, you will, on average, have the same length. And this requires you do the addition step before you do the deletion step. and you need a slightly lower. So this gives you a slightly lower deletion rate than addition rate. Um, right? So if the deletion rate, say, is 1 in 10, so it would be 0.1, you divide by 1.1. Yeah, so it's going to be a little lower. Okay. So the deletion rate is going to be a little lower than the addition rate, and that's necessary. Actually, I don't have very good intuition about why that's the case. I mean, I've done the math, so I know it's true. So actually here, this sentence here probably is useful. So in the extreme case, let me make that a little bigger. In the extreme case of an addition rate of 1, that means we're going to add a gene at every location. Then the genome will be twice as large as the parent. And in order to reduce it to the parent size, we need to remove half the genes. So if we started with 100 genes, we now have 200. We need to get back to 100, so we want to remove half the genes. So we need a deletion rate of 0.5, right? And if the deletion rate was 1, if it was the same as the addition rate, we would delete all the genes and we would get to 0, not back to 100. So that makes sense. That's a useful example. Good job, authors. So this is the sort of recommended, it's not required, but it's sort of the recommended approach. We never actually implemented that. So if we look at our implementation, let me close that, of UMAD, there it is. We have, backing up, so we have our addition and deletion rates. We also have an empty addition rate. This is the likelihood of adding a genome if we find ourselves with an empty, or adding a gene if we find ourselves with an empty genome. And that's an option which is a way of saying maybe you don't want to do that, but if you do, you can set that. And we have a new constructor that takes an addition and a deletion, and a new with empty rate that takes an addition and a deletion and an empty addition, and a new without empty. So new assumes that empty addition is the same as addition. So it puts a sum addition right there. If we specify a specific empty addition rate, we put that in. If we call new with empty, we just don't have an empty addition rate. We set that to none. None of these use the default. Use that sort of deletion equals addition over 1 plus addition. And we really probably ought to have that. And I looked, and in at least one example, and I'm willing to bet this is true for all the push examples, I used new, and I think this is on me, with 0.1 and 0.1 as the two rates. So I'm definitely not using the default system, because this deletion rate ought to be this over 1 plus this, so 0.1 divided by 1.1, whatever that is. 0.1 divided by 1.1, 0.090909, yada, yada, yada. So that means in all my examples, the deletion rate is arguably a little too high. So there's actually a bias here towards smaller programs. Our programs tend to shrink over time instead of grow, which is, I don't know what that means, because we certainly had good results, but this does seem a little weird. Now I also want to look because there's data here with different rates. I thought. Okay, yeah, here we go. So size neutral UMAD has an addition rate of 0.09, so a slightly lower addition rate than ours. And I don't know if there's any argument for why that number was used. I honestly don't remember if we had any justification for using that number in particular. That's an interesting question. What if I search 0.09? Where is... Hello? Come on. That is not helpful. Where is the 0.09 that it claims is on this page? I don't see it. Oh, well, there's one. It just didn't highlight it. So these are different addition rates. So basically, their default, and then half of that and twice that, and they had much better results on syllables with half, and slightly worse results with half on everything else. And doubling mostly made things worse, sometimes even statistically significantly worse. It actually made this better, but that's probably not a statistically significant difference. This made this a little better, but again, probably not a statistically significant difference. 20 versus 19 probably doesn't matter. Well, hello, Vagary. We're discussing a gap in the implementation of UMAD in the unhindered-ec project. In particular, this is the UMAD paper. Oops, let me scroll back to here. The deletion rate, if you want on average the sizes to not change, the deletion rate should be addition rate over 1 plus addition rate. We never actually implemented that. And I knew when we implemented UMAD that there was math like this out there. And I just, I didn't take the time to look it up. I didn't remember it off the top of my head. And that's something we really ought to fix. And since I'm the only person who probably, I did make it an issue about it, but I'm the sort of only person who knows that this is a thing. Oops, I wanted to be back here. I figure out how to do something about it. So I was thinking I might actually try to deal with that quick. We use UMAD as the primary mutation operator in all of the push examples. And it is in the push group, it is the primary operator that everyone's using. It's demonstrated itself to be very successful. So the main thing is we don't provide this default deletion rate equals addition rate plus over 1 plus addition rate. We don't give you let me back up. Given this relationship, there ought to be a constructor for UMAD where all you provide is an addition rate and it computes the deletion rate using this formula. We don't have that. And when I use UMAD, I just plop in addition and deletion rates, and they're always the same. So my deletion rate's always a little high. That ought to be 0.09 and it's 0.1. And so what we probably ought to have is, a something like pub const fun new with default deletion, something like that. Um, so that equation is so this equation gives you the right deletion rate to use so that on average your child is the same length as your parent. And that's an on average, right? So if you don't do this, if you do what I did here, that means my deletion rate is a little high. Oh, it is, absolutely. Carrying a lot of water. My deletion rate's a little high, which means that there is a slight pressure for shorter programs, which I find particularly odd because I've also found that with our system, it's a good idea usually to start with very short initial programs and let them grow toward the solution. Whereas the standard in the closure universe is to start with quite large programs, like 100 or 200 genomes or genes. And then they often shrink some, or they just stay big, and you hope that simplification makes them more readable. But if we start with little things, then they tend to grow nicely toward the solution in a way that I think is actually quite useful. So it's interesting that we have a slightly higher than desirable deletion rate, because that deletion rate you would think would keep things smaller. So I don't know. Maybe I shouldn't care. Maybe I'm overthinking it, and we do have an issue for it. So there is a documentation for it. I feel like somewhere. Okay, so here, well, that's a little weird. So they don't actually do one where the growing and the shrinking, the adding and the deletion are the same. So they use 0.9 for the addition rate, 0.09, sorry. And then they, I keep saying they, I was actually part of this, so I should not make it sound like it's somebody else's problem. We used a deletion rate of 0.1. Why did we use a different one? Why did we use I guess, that's very strange. Don't really know quite what the justification for some of these choices were. Okay, well, vagary thinks it's a good thing to fix. Let's fix it, because it won't be hard. And then we can see what the impact is, if any. So actually, I want to undo what I did here, because I don't want that to happen in this branch. Actually, let's go over here. And whoa, I've got uncommitted work. Oh no, that's not good. Hello. Oh, I haven't saved. That's why. If I save that, hello. There we go. Then I can discard that. Boom. That's going to be faster. So actually, pause for a moment while I actually commit some work that needs to be committed, which obviously I didn't get around to last week. So this was on the push readme. What did we do on the EC linear readme? Oh yeah, we moved the examples, or introduced the examples section, and added the uniform crossover illustration. And that's this guy here, so they should go together. Add examples section and uniform crossover diagram for EC linear. And that probably... Hello, Eustace. How you doing? I'll explain in a second what we're doing. We're sort of stepping away from the README for just a second. I don't think it'll... Well, famous last words. It won't take very long. But there's something I want to fix. And so, but it turns out I didn't commit the work from last week. So it looks like I'm in the READMEs fixing things because I am. So I don't think I have anything very exciting to say there. No problem. And then this adds the example section, and this really basically adds, hey, Wagatha, I started reading your thing. I'm sort of like a quarter of the way through, and then dinner happened, and then I got distracted and didn't get back to it. But I am reading it, I promise, and I'll try to get to it, finish it today. And I don't know how... I'll probably send you some stuff on Discord. I think it'd be the easiest way to send you some comments. But so far it's been interesting. And as somebody who... I've lost the title, the name now of the thing. As somebody who didn't know anything about type level programming until you brought it up a couple of months ago for the first time. This has been very interesting. So thank you for sharing. I appreciate it. So yeah, I'm on, I'm out of 4 pages, I'm somewhere on page 2. Yeah. And pretty minor comments. I think I found one mistake, but just typo mistake. So this creates a README for push. And I should say, we love having you, even if all what you do is lurk. So that's awesome. You know, whatever we can do to boost the algorithm numbers, right? Whatever. That's meant to be a joke. Sorry, because I'm clearly not doing this to boost algorithm numbers in any meaningful way. I have been, speaking of algorithms, I have been managing to consistently post streams to YouTube since I started again a few weeks ago, a month ago, whenever. So those are there, and they're getting, small numbers of views, but that's what we'll expect. I mean, but they are there if that makes anybody happy. Yeah. So that was one of the things I was wrestling with a little bit, is there are some places where if you wanted to get picky, there are probably some grammar issues. But I'm mostly trying to not get into that. I mean, I think as long as things are readable, and they generally are very readable, I want it to still sound like you and not sound like me pretending to be you or something like that. So I'm mostly not getting into the weedy bits of English grammar. If you want me to, I can. But like I said, I think it's very readable as it is. And I think it makes more sense to focus on that than worrying exactly about whether that's a sentence fragment or a comma splice or whatever. So to answer Vagary's question, here's the link in the chat. If anybody's hot to, oops, what am I doing? I'm going to be over here. So this is, I hope that will work for people. I think it will. I don't think I'm logged into ACM and have any special magic privileges. So I think that link ought to work for anybody to get to this article. So then what am I doing? I was back here. So, excuse me. Sketch out the push package readme. I don't know that we have anything to say there, really. Excellent. Glad to hear it. Okay, so I'm going to push those guys. Now, then, if we want to fix this other thing, what was that issue called? It was align UMAD. Align UMAD. Boop. Create a branch. Go team. Oh, but I just created it on the wrong thing. So I can move that branch, though, if I'm smart. Let's see. What do I do? I want to move. I want to move that branch to here. Da, da, da. Why is there not I swore there was a simple, like, move this branch to there. Maybe not because I created it too high up. Oh, reset to this commit. There we go. That's what I wanted. Boink. Okay, so now we're down here. Excellent. So the issue is we should... Why is this red? There we go. Okay. It just needed to reset itself. The issue is we should have a... actually, probably easier to look at this. We should have a constructor for UMAD that sets this deletion rate to the default. Excuse me, I have the coughs at the moment. So we should have pub const fun new with default deletion, and I should have some comments on that. That takes an addition rate, but no deletion rate, and a gene generator, and returns self, and is self, addition rate, deletion rate should be addition rate divided by 1 plus addition rate. And empty addition rate will go with... Oh, actually, I could call new, couldn't I? And just put the right thing in. So, yeah, well, and this is one of the huge issues, and I haven't looked at Charles's. So, rolling back a second, Vagary and I I hope you find your headphones. I left mine in Morris on the whole trip to Wisconsin and Kentucky and back. So annoying. I thought I'd lost them, and then my wife found them here and was like, "Did you realize you left these?" I'm like, "Meh." So, rolling back to Vagary's comment, I think one of the things, and I've said this before, I'll say it again. I'm an old man. I'll repeat myself. Clouds. I think one of the things that's so tough about evolutionary computation is that almost any mistake looks interesting. It's very hard to see mistakes because you're evolving stuff. As long as stuff evolves, it looks like you're doing a useful thing, which means that mistakes hide really, really well. And I think there's a lot of wrong implementations of a lot of things. And obviously, there is nothing wrong with your implementation of UMAD. The problem is, from a scientific perspective, if you are to share your results and say, I got these results using UMAD, and people exactly change it and keep better stuff is evolution. But if you don't know and you don't say it out loud, right? If you tell everybody, I got these results with UMAD, and they're like, oh, I will use UMAD as documented in this paper because I assume that's what this person meant. And then they don't get the same results, then we don't have science. We have like weird people doing random things. And so, and in some ways, it's totally fine if we discover something by making a mistake and then realizing the mistake's better than what we meant to do. That's fine. But you still need to say out loud what it is you're doing and to do that accurately. And I haven't looked at Charles. Yeah. So yeah, exactly. And I haven't looked at Charles's thing yet. So I need to do that. But yeah, I feel like that's one of the things that I would want to say really loudly and clearly is that, if you're going to build a system, try to be careful about it and get it right and document what it is you did. And I think that there's less of that over time than there used to be. And that's probably not good. Okay, so I did all this, and really I could have just used new. So I think I want self, new, addition rate divided by 1 plus addition rate. Actually, I'll come to that in a second. And then gene generator. Boom. Yeah. That needs to be 1.0. Fine. And I'm actually going to pull this out. And I think I can extract into variable. That's what I want. Yeah, bingo. That is exactly what I was after. So, and that way I can document using this deletion rate means that on average, the child genome will have the same length as the parent genome. And then we can actually say here construct UMAD with what happened there? UMAD with balanced deletion rate. If the deletion rate is set to addition rate divided by 1 plus addition rate, then on average, the child genome will have the same length as the parent genome. So it feels like there's another paragraph missing. Maybe it goes the other way. In this. Good job, Eustace. I'm glad you found them. Where this constructor just takes an addition rate. Good job. Glad to have you fully here. And computes the balanced deletion rate. Blah, 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 blah. Okay. Okay, fine. Yes. I was thinking about that and probably should do it. So I'll take your word for it there, computer. Backticks for unbalanced. Oh, of course they are, because I've added two. Added two at the ends. Okay. Cool. So that should do that. Do we have any tests of consequence? Oh, we do have some tests. What do these tests do? So a UMAD. Okay, so we have a UMAD test. Oh, which we ignore because it's stochastic and it fails sometimes. Yeah, that's the issue. So I was just checking that we with fairly high addition and deletion rates that we would add at least 1x, and that we would delete at least something. But that can fail because statistics, and we run the tests a lot in the CI chain. So that's why I think Justus ignored that, which is entirely reasonable. Okay, so there's not really anything useful on the test front there. And then here, which one is this? This is complex regression. So we ought to be able to change this to new with default deletion and get rid of U. And now we ought to be able to come over here. Oops, exact-ish. Cargo, run, release, example, complex regression. Very good. And so we'll start with just one instruction and see what happens. Do we still get useful things? Yep. So, no. Ooh, weird. So we actually had empty as our best. That's very strange. And this is just using total error to decide the best. And then pop, we actually solved the problem. So there must have been programs that were attempting to solve the problem and just had worse total error than 32,000 until, boom, that happened. So, ba-doop and ba-doop. And if we start with something bigger, like 100 instructions, yeah, so it's a lot slower with 100 instructions. Oh, and did that just ended? It didn't actually finish. Max generations. Well, let's say 500. Let it go. Whoops. Generations. I even said plural, and I typed singular. Well, that one found the solution pretty quickly. It's a nasty solution. And I should catch up on the chat. Yeah. And it is amazing the things that require accounts that you wouldn't think would need an account. So actually, Vagra, I didn't realize that you added blobs of instructions, whereas in the paper, we just added a single instruction. And, again, like, that's a great example of, is it really broken? No, it's just different, right? So the add proportion that I'm using is 0.1. And so then the deletion is 0.09 something, something, something. And that is actually, hang on, that is really high, right? Because in the paper here, no, it's not. Because we used 0.09, and 0.1 is pretty close to that. So we're using yeah, and that, so Eustace's comment is important and would probably need to be documented more clearly somewhere. And if we were to ever publish something with this, probably that's a thing we need to say something about, because yeah, that's what the empty addition rate is about, is what to do if you ended up with an empty genome. Empty addition rate. Boop, 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 boop. Yeah, so if the genome size is 0, and if we have an empty addition rate, then we return a new gene. We flip a coin and decide to whether we want add a new gene or not. And we set that by default to be the regular addition rate, but we can leave it as nothing, in which case you just get your empty thing back. Yeah, so right. So it's add a gene next to 1/10 of the genes and delete roughly 1/10 of the genes, which, if you think about it, really is, as you said, very disruptive. Like, why does that even remotely work? So you're suggesting changing this 0.1 to like 0.01, something like that, I think. And then see what that does for us. Based on the paper, that would probably make it worse. And since we don't have any other mutation or crossover operators, it's certainly going to slow things down. The rate of change is going to be very slow. It's also important probably that in push, lots of change doesn't matter. So there are a lot of instructions that don't do anything, and inserting instructions in a lot of places won't change anything. So that ran 500 generations and didn't find anything. We'll do it one more time. And so having higher than might make sense mutation rates. Oh, there we go. We found a solution in 129 generations. And if I change, what if I change the initial instructions to, let's go crazy and go back to 1. I'm curious to see what happens there. Okay, well, we got into some actual programs and we solved the problem in 238 generations. Well, ain't life weird? So it was able to actually insert enough stuff starting from basically empty to eventually find a solution. Is this going to work? Are we going to run out of time? Oh, we found a solution just in the nick of time. So, we can make it work. So do we delete first? Because I think is that another place where we're different? Because I think here we go. Yeah, so in the paper they add first and then delete. What did we do? Did we invent a whole new operator? Because that's what, people do. Okay. Because we did that. unhindered-ec came up with a trick that we did it in 1 pass instead of in 2. So we have, for a gene, we decide whether to add a gene, and then we decide whether to delete the gene we're looking at. this gene, not the new gene. And this decides whether to delete the gene we just added. And this gives us an option, which is none if we remove the old gene, and some of the gene if we kept it. And this is the gene we added if there was one added, and then we get this pair of the old gene and the new gene. So we are doing the addition. Yeah, we did it the right way around. We do the addition, and then we do the deletion. Just unhindered-ec helped sort of rearrange the code, so instead of making two passes like my original version did, we do it all in a single pass, and then flat map ourselves up into one big pile of goodies. When you say that's stupid, what is that in that sentence? There are many things that we've discussed that could be stupid. But we did do it the right way. So yay us for that. And wonder if we change it to something more like 0.05. Yeah, that was much faster. Oop, that one's taking a while. But still 200 versus 400. So yeah, slightly higher seems to be better based on some eyeball statistics. And if we go back up to 0.1, and to be honest with you, I don't think it probably matters a lot that we have this deletion be exactly the right thing, but I would like to at least be consistent with the paper, or provide a way to be consistent with the paper, unless we have a reason not to be. So so you think that it would be faster to delete first and then do the addition? I'm not sure I see why that would be. Why that would be faster. And yeah, we could totally do a quick test with hyperfine. Right. I mean, so vagary, yes. So if you did the deletion first, you'd have to. Yeah, I'm not sure I'm seeing what Eustace is saying there. So I'm guessing. Yeah, well, I think vagary, looking back at your comment about strong feeling there is a steep transition, I think you're totally right that it depends on a million things, right? This is one of the things that I always end up having to talk with my students about is in evolutionary computation, the answer is always it depends, and it does always depend, and it depends on so many things, which makes it so difficult to compare apples and, even another plant, not to mention, mammals and rocks. So yes, the evolution is mysterious and important. I think there's a shirt there somewhere. So, okay, but this would at least, by adding, I haven't seen Severance. It's on the list of things that ought to be done, but there are so many things to see in the world, and so few hours in the day. So I think having this is probably a good thing, and I think probably switching, it probably makes sense to switch all the examples to use that. UMAD, new, with default deletion. And what is that? That's median. Just to be paranoid, I'll run everybody. Oh, come on. Median. What? Whoa, that was fast. Oh, but median is really easy if you have clamp. Yeah, if you have clamp, median is like super simple. So it's very fast. So really, to be like the median problem, should actually have store this line to remove clamp from the instruction set. Dot filter boop bop bop boop. Yeah. I not equal to int instruction clamp. Oh, that's a little awkward. Is it gonna work? I think so. There we go. And so now it just has to do a bunch of mins, which is still pretty easy, but it's not as easy as it was with clamp. Call it with balance deletion. Sure, I have no problem with that. Where'd UMAD go? Hello. There you are, UMAD. With balance deletion. Yeah, that's a better name. I like that. With balanced deletion. Yeah, this is part of the problem, arguably, with Clojure in particular, is nothing's ever been removed from the Clojure implementation. And even things that were just demonstrably, like, were just something that Lee played with for 10 minutes, found didn't work, but he left in. And so that's an issue, absolutely. In this case, because all we're doing is providing an easy way to set a default value for a parameter, I'm not too worried about it. But yeah, there's a lot of code hoarding in the Clojure's code base. And that's the whole reason the propeller code base was created, was to be a very simple subset to use in. So Tom Helmuth created that as a simplified version to using classes. And then because it was easier to understand, a bunch of people switched over to using Propeller instead of Clojure. And now Propeller's grown to become a blob that's difficult to think about. And I think there are some bugs in Propeller. So, yeah. So construct UMAD with balanced deletion rate derived from addition rate. Yes. I think that's a good idea. Well done. Thank you. I think those are good improvements. Okay, so median, what else do I need to change here? examples. Oh, what? That was weird. Examples, number IO, main. La da da da, UMAD. Da 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 da, right there. New. Oops, didn't want to do that. Hello. With balance deletion. There we go. Da 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 bum bum bum. And so this is number IO. Make sure it works. Go this way. Number, oh, stop it. Number IO. I don't remember, is it dash? I think it's underscore. I think maybe it doesn't matter. And we win, which is not surprising because that was a very easy problem. And then example, simple regression, main, UMAD, new, with, balanced, deletion, boop, boop, pop. And this is simple regression, da 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 da. Simple regression, go little computer. And we succeeded, yay us. And then the last one, I think there's one more, examples, yes, smallest, main, new, with balance deletion, da 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 da, comma, and oops, this is what this is smallest, da 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 bum bum, smallest, smallest, boom, and we win, yay! And I think here, if you just have enough int mins, you solve the problem really easily. So that makes that a very easy problem. Okay. Hyperfine's awesome. Highly recommend. Oh, that's too bad that we don't have that posted. If I could find which one, I mean, I have pretty good notes, so I probably could find the one. I could probably find the video and move it over to YouTube, because I have an archive of all the videos. I just got lost on posting them to YouTube. Okay. I hopefully I could do some searching in my notes in Obsidian and find it. So yeah, so more example problems, absolutely, and certainly some harder ones would be good. I mean, we only have a handful, and they're all very easy and very solvable. So the and I have been thinking about sort of doing, I mean, my goal in some sense would be to have just all the PSB problems implemented. But that's the issue, right? Is that there's been these conversations about rewriting the push interpreter in a variety of ways. Izitsu has a version called braces that comes from a lot of conversations here. I know Justus has a bunch of ideas. And so there's this question of how much time do you put into implementing all the different instructions? Like right now, we don't have any support for char or string or vector, and you would need that to do a number of the PSB benchmarks. Um, and none of that's hard, but it's time consuming and it creates more code that kind of weighs down the existing system, and makes it less likely that anything ever gets changed. On the other hand, waiting for change that never comes doesn't buy you anything either. So it's a tricky bit question, um, but it would be nice to have more examples. That was definitely something that came up in the class, that it would have been nice to have had some of those types and more examples. And if I thought um, if I thought I was going to teach the class anytime soon, as opposed to I'll probably never teach the class again, which is actually the reality, um, I might have different feelings about what my personal priorities would be. But given that the class has happened and I'm probably not going to teach it again, but that said, like we could. Yeah, that's an interesting point. Um, I think the biggest challenge is that the more complex problems. I mean, I guess we could do your birthday problem, right? That doesn't require any more types than we have now, and we know that the birthday problem is challenging, um, and so we could do that. um, uh, we could also do just more complex regression problems. There must be examples out there of tricky regression problems, that people have struggled with, and we could implement some regression problems. That's not a hard thing to do, and it doesn't require more types. Um, so if we wanted to do that kind of work, we could do that without actually having to add a bunch of types. Um, so I don't know. Do you have suggestions? Yeah, right. Uh, and there are regression problems that are based on real data, right? So actual data collected in the world where people were trying to find um, uh, programs that matched real world data. And so that's a possibility, right? We could find some of those. The fast Fourier transform. Part of the challenge there is that you could tell it you want to do a Fourier transform, but the fast part's the tricky bit, right? You'd have to build some kind of performance metric into the notion of score, um, uh, because it could just like find some stupid way of doing it. But things like that are done, right? I mean, Google's been doing stuff recently. Um, yeah, so right, you could do sine or cosine without the trig instructions. That's been a very common one, uh, that people have done. I've seen that. In fact, I'm pretty sure in the field guide to genetic programming, I think the flip book example in the back, in the bibliography section, is evolving a simple program to match sine. And if you do a polynomial over one cycle of sine, so from 0 to 2 pi, you can get polynomials that match that quite well. And then, of course, they just go crazy outside of that range, but because they sort of have to. It might be interesting to try it with a longer period, like several, go to 4 pi or 6 pi or 8 pi, and that would be a harder problem. It would require a higher polynomial, higher degree polynomial, to try to get something that matches. So, so yeah, Taylor expansion, right? That totally is a thing, that we could do. That would not be hard. We can do that like right now. Um, Now, when we don't have, so this is another piece of instruction that we don't really have, is we never implemented the most of the looping stuff, in part because of this question of, are we going to rebuild it or not? And so we're pretty thin on exec instructions. And one worry I have is that may be part of why it goes fast. Is that we're missing some of the instructions that are problematic. We do have dupe, and dupe get used right here, exec dupe. So there's dupe and exec dupe. There's int dupe. It's not being used here anywhere. That's interesting. So we've got dupe, and dupe can create its own set of fun. So we really, before we say anything too loud about how much faster this is, probably really need to have a more comparable instruction set, because the instruction set can definitely impact performance. So, no, we actually don't. I don't think we have any looping instructions. Okay, not EC linear, not example, source, instruction, exec. Yeah, we don't. We have dupe, block, if else, no op, unless and when. Yeah, not even doing. Well, I mean, actually, I guess we could implement exec Y, but I am not a fan. But no, we don't have any looping. And I think actually, like, if you look at the evolved solutions to the more interesting problems that the other systems give you, you're much more likely not to have a generic looping instruction. You're much more likely to have something like a map that says do something to every character in a string, or do something to every item in a vector. And the generic looping stuff rarely works. And I actually have my suspicions that the way while is implemented in Clojure is just never going to work, frankly. And I think the fact that you don't see solutions to a lot of things like GCD is because the while is just not designed well. So the exec Y, okay. Y Combinator Wikipedia. So this, oh no, I don't want that. This is what I want. There we go. So there are these combinators in lambda calculus, and one of them, which is theoretically very interesting, is the Y Combinator, which lets you create anonymous recursion. So you can create recursive definitions without providing a name for the function that is recursive. And the details are a little whack, and I'm not going to probably go into that right now because that would be a distraction. But this is a very important thing in lambda calculus, so that you can do recursion without having named functions. And there are other combinators. There's the S combinator, the K combinator, the I combinator. Is there like a list of these things? I wonder if combinatory logic. Is this going to have like... so they're summarizing lambda calculus, don't care. Oh, here's yeah, okay, here we go. So the I combinator is the identity. It just takes X and returns X. K is a constant. So K of X applied to Y always returns X, so it ignores its second argument. S, its second argument is a function, so you get x applied to z applied to the result of y applied to z. These are all, in theory, useful, although I found S is also problematic. K and I think, are completely reasonable. And then Y, as Vagary said, basically just gives you infinite loops all the time. And it's really annoying to have in the system because it's very easy to generate infinite loops, which is, I think, a problem. And in the standard push setup, you run until you run out of time. So let's say there's a generation limit of 100. If you haven't found a solution, you just stop at 100 and take whatever's on the top of the relevant stacks as your output. And so it's very easy for evolution to say, well, figuring out when to stop is hard, so I'm just going to go forever with the S combinator and count on the push runtime to stop me at some point, and then hopefully the right thing will be on the top. And I think that that's problematic in a variety of ways. And I'm not a fan. And so I think the Y combinator is just not a good idea. That said, Lee Spector loves it and really wants to keep it in the world, and will argue vigorously that it's, a useful and important thing, I think, without very little actual evidence. Like one of the things that I've heard said, I don't remember who said it, but somebody went and looked at the evolved solutions to a bunch of problems and said, hey, there's a lot of Y combinators in these. It must be important. But again, I think that Y combinator is just doing infinite loops and bleh. So, okay, enough banging on about that. Okay, so I think I've updated all the examples in push that use the UMAD to use the default, the new with balanced deletion, which I think is a good name. And we added a little documentation, so yay us. Do we have square root and square instructions? We might have square root. Do we have square? Good question. Instruction, float, SQR. No, apparently not. Really? Abstract, multiply, divide, equal. Oh yeah, we don't. Actually, we don't even have sine and cosine and things like that. We must have just done kind of a minimal set of floating point instructions, because we've got more, I think, in int land. I feel like int's got more stuff. So is 0, is positive, is negative, is even, is odd, equal, not equal, less than, blah, 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 blah. Oh, no, we don't appear to have like square. Oh no, here's some more stuff. Oh yeah, we got square for ints, but we don't have square for floats. And we've got power and mod and min and max. We didn't have any of that stuff for float. So yeah, float is under implemented. And so there's more instructions that need to be added. But again, since we were talking about rearranging the whole push interpreter, it wasn't clear that we wanted to put a lot of work and effort into that. Blah, blah, blah. Yeah. What time is it? Oh, it's 11:14. Okay. Should we, is there anything else on this UMAD change that needs to happen, or do we think this is good? Yes, I'm definitely not suggesting we do it now. Um, but it's good to ask. I mean, and I don't know if there's an issue that sort of says that float is under implemented. Float. Gloat? Huh. The gloat stack. Well, there's this very general thing, but yeah, it doesn't look like. Um, so, so how did we get to the UMAD change? Well, I was that that's bugged me on and off for a while. I don't know when I created this. So I created this issue almost a year ago, and for some reason, before today's stream, that neuron fired again, and I was like, "Do we? Did we even document this?" And I looked, and sure enough, we did. And so then I went and found the paper just to confirm that there was actually math here. And then I looked at our code, and we didn't do it. And so that was just all in my head when the stream started. Yes, we did document a lot of issues, which is, we need this whole team of people to come join us and complicate the world. And so I was just like, while I'm thinking about it, and because I don't think it'll take very long, then it's taken longer than, as everything does in this stream, it's taken longer because we've had lots of conversations about lots of things. I figured this wouldn't take all that long. And indeed, it's good that we documented a lot of things. And frequently we documented things because you said we should make an issue out of that. Instead of me going, I'll remember that later, because I don't remember anything for 10 minutes, as everybody knows. So then I was like, well, let's fix this quick. So quick was an hour and a bit, but I think we're in a place where we could commit this and make a pull request out of it. So that's the new code. And the rest of this is just going to be, that probably should be commented out again. So that's median. Where is median? There we are. Boop, bop. And then that's just adding that, and that's adding that, and that's adding that. Okay, so with this, the random things that I remember when I can't remember the syntax for turbofish or something useful, it's just mind-boggling. Ask my family. So add new with balanced deletion to UMAD. This actually this closes. What does this close? This closes, oops, no, I want to be here. This closes 286. 286. Adds a new constructor for UMAD, which calculates the deletion rate, calculates the balanced deletion rate based on the given addition rate. So I don't know where the interpreter rewrite is. Like I don't know. Like this is I think this is something where um, I would defer in some ways to Justus um, as to how Justus would like to organize that. Um, I think that my goal at the moment is probably to not become the project manager for this thing, um, and because I don't think I'm good at that, and I don't think it's what I want to sort of be doing right now, and so I'm more than willing to help, but I don't know that I have a sense of the timetable. But if you're gonna do a Swift interpreter rewrite this week, then we will be later than you. I think that is absolutely clear. Um, and I think, in a perfect world, which is a complicated thing and probably not the universe we live in, but it would be interesting to have like 2 or 3 even different interpreters implementations and do like real performance comparisons and try to figure out where the issues are, and make an informed, thoughtful choice about what version we do and why. But that requires implementing a bunch of things, or at least implementing proof of concepts of a bunch of different ways. Um, um, Gotcha. Um, so, but it could be something that starts this summer, right? And that would be nice. So, it would be interesting to see where that ends up. Yeah, I think the developer ergonomics of using it absolutely should play a role. I would agree with that 200%. That if we want people to use the thing, we need to make it so that they can fairly easily use the thing. 300%. Yes. See your 300% and raise you another 150%. So yeah, I think we want this to be usable, and we want it to be extensible, because people are going to want to have new types and new instructions. People are going to be like, oh, float doesn't have square root. I really should add square root, right? And if that's hard, then that's bad. So it's a full-time job, and I love it, but I don't want it to be my full-time job. So, okay. So I think that probably does what we need to do there. That does not even slightly surprise me, Vagary. And I think you build an entirely new GP system about twice a year. So Vagary has built more random, and I shouldn't say random, that sounds pejorative. Vagary has probably more experience building stuff in evolutionary computation than just about anybody I ever know. Well, okay, we can go with random bullshit if you want. But Vagary has built a lot of stuff. I mean, if I needed to talk to somebody who has experience building systems like this, Vagary would be top of the list as somebody to talk to. Yeah, we have spent many hours talking about these things over the years, and Vagary's a pretty smart guy about this stuff. So okay, I think I'm going to call that a win, and then I'm going to just plop all these in, as a big group. Change push examples to use balanced deletion. Changes all the push examples. Oh, I'm just going to repeat the title. Skip it. Okay. So then if I push this, Boop-a-doo. It's very windy out. Our red-twigged dogwood is banging against the window here. So if there's weird wind noises and stuff, that's what's going on. Oh, yeah, that would be a good idea. Okay. So I think we'll just say add UMAD constructor with balanced deletion rate. Well, the commit message is gone now, unless I do force commits and stuff, because I did not get that. I did say I did. Oh well, there no. It doesn't say mutation anywhere. It does say UMAD, so I got that part, but I didn't get the mutation rate. So oops. So actually, if we take this, because that was not a terrible sentence, for the UMAD mutation operator, oh, I see. I'm terrible at remembering students' names. I got better at it over time because I learned some tricks that helped, but it's not been my strong suit. Oh, I'm not a fan of force push. I mean, I think force push, especially once things are out on the repo, if there are other, I mean, in this case, there aren't other people involved. So, but certainly when my students are working on projects and all the students are like, interacting with things in parallel, force push is just a way for them to shoot themselves in the foot. So I tend to discourage that. Well, but usually, again, with my students, the feature branches are things that are being worked on by multiple people, um, uh, not single people. And people may have merged your feature branch work into their work for some reason. And if you force push, it makes a mess of the history. And so I think it can be problematic. It depends a lot on how your group of people are working together. So, um, and see, I almost always do a PR right away because I think it's useful. Um, I think it's useful to have the PR there from the beginning for people to talk about instead of waiting until the end. So I don't know force-with-lease and forced-if includes. I have no idea what those do. Get force-with-lease. We're going to get an AI summary. Is a safer alternative designed to prevent accidentally overwriting of remote repository changes. It forces a push, but only if the remote branch is in the state you expect. It acts as a compare and swap operation. Checks if the remote branch's current state matches the state it had during your last fetch. If they match, the push proceeds. If they don't match, that would mean somebody else is pushed. And that, okay, that makes sense. I like that. See you later, Vagary. Wonderful to have you here. Thanks a lot. I hope GPTP went well, and say hi to peeps. We'll talk to you later. And then force if includes. Force if includes. Oh, I didn't get a summary there. Well, that's annoying. Because that summary was sort of useful. So let's see. Force if includes does nothing unless you also include force with lease. Oh, so you do have to have both of them. So this doesn't actually, okay. So this person is not a fan. What is it? This doesn't say what it does, though. This is. I want a shorter answer. Force if includes. Boom. Specifying force if includes along with force with lease at the time of push will verify if updates from the remote tracking refs that may have been implicitly updated in the background are integrated locally before allowing a forced update. I don't know that that tells me very much. Force an update only if the tip of the remote tracking ref has been integrated locally. This option enables a check that verifies if the tip is reachable from one of the reflog entries of the local branch based on in it for a rewrite. Check ensures that any updates from the remote have been incorporated locally by rejecting the forced update if that is not the case. Ugh. Well, maybe that's why that guy's write-up was so long, is that this is not a trivial thing to explain. Verifies that the tip of the remote tracking ref is reachable from one of the ref log entries of the local branch based in it for a rewrite. This ensures that any updates from the remote have been incorporated locally by rejecting. So what does this do? Does this mean like would this save me if you did a force push and then I tried to do a force push and we would bang into each other? I'm not really sure I understand what this accomplishes, to be honest with you. Well, let's get back here. UMAD, uniform mutation. Is it through or with? I honestly don't remember. By. It's neither of the things that I said. By addition and deletion as described in doodly-doodly-doo. What's the title of the paper? Program synthesis. Actually, then I probably don't need that because that is in that title. But it would be good to have a link. Doop-a-doo, doop-a-doo. Boop, bop, boop, 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 boop. So this just ensures that you're on the same or newer state from the tip of the current remote branch. Basically, you aren't pushing while being on a past commit if you have fetched the new commits already. Oh, use the DOI. That would be nice. Yeah. Let's do that. Copy link. Good catch. Thank you. So if I've fetched commits but not moved forward to include them, and I try doing a force push, that's going to stop me. So if you've pushed some things and I fetch those changes, but I'm still behind those, I fetched them, but I haven't merged them or brought them in some way, and then I can't push from here without first getting caught up. Okay. Do we still have issues where, maybe not. I was wondering if we still have issues where, because I feel like the in the past at least, the danger has been that if you force and I force, or you force on something where I have stuff checked out and work happening, it messes my universe up, because you're basically rewriting history that my version of the world depends on. And is that still a concern? If multiple people are working on the same branch, or do these things prevent that from getting in the way? So UMAD, as described in blah, recommends using a balanced deletion rate, which is $2? Addition rate over 1 plus addition rate. Does that actually do the right LaTeX-y thing? Look at that, it does, except for it totally didn't do what I wanted. So I probably need to actually, yeah, that's the problem with text RM. Boop. Now, is that going to work? Yes, it is. Okay. Text RM. Boop. And text RM. Boop. And there we go. If one, so is it, you say it makes it a lot harder to accidentally overwrite stuff. I feel like the issue that I've run into or my students have run into in the past has partly been overwriting, but also partly creating merge conflict issues, where if multiple people are forcing things, there were became very confused about who did what when, and you got some very strange merge conflict issues. So a branch from the branch you were updating, but branching from branches is always a risky business anyway. Okay, so if you use the force with lease and force if includes, things are generally safe. Interesting. I wonder, I don't know. Can, so like if I change this, oops, up the push examples to use a balanced deletion rate for the UMAD mutation operator. To use a balanced mutation deletion rate. Yep, you're completely right. You wanted mutation. Yeah, you wanted UMAD and mutation to both be in the commit, right? Yes, okay. So does that get us there? To use balanced deletion in UMAD mutation. For UMAD, that's better. Yeah, I like for UMAD. For UMAD, okay. So if I say update message, and now, right, so now I'm off here. So I have to, this would be where I would force push. Now might have to go to the command line for this, but I'm just curious to see if I can, if I say just push, it just gives me force push, but doesn't let me specify those options. So I would need to come over here, get status, so get push minus force. What are the two things? Force with lease and force if includes. So I just do that, and in theory, magic will happen. Squeaky face. Okay. So it didn't say anything unhappy happened here. Now, oops, no, I don't want to be there. I want to be here. Oh, I hadn't actually created the pull request. Probably should have created the pull request first, but because then it would have been more interesting. But this did update. No, this is still looking the same because I'm probably in this edit thing. Let's just draft something. And then, yep, that did update both of these. Cool. So now I want to continue to write this. If you use this deletion rate, then on average, the child genome will have the same length as the parent genome. This PR also updates the push examples to use the new UMAD, new with balanced deletion constructor. Ooh, I like that. This ensures that I think I'm going to stick with on average genomes maintain the same length. The same length after mutation. It probably is modelable as a random walk. That's probably true. I'm not sure I understand. So are you making an argument that this really ought to stay statistically rather than on average? Oh, out. Don't want to do that. Stop. Closes 286. Yes. I think I'm going to say on average. Make sure this link works. It does. That's a happy thing. And that is the right deal. Labels. Examples, experiments, mutators. That's what I'm after. An improvement. We're not really calling for participation because it's basically done. The UMAD operator. I don't know anything about polarization mode dispersion. So that sounds cool, but I don't know anything about, I know about random walks, but I don't know about polarization mode dispersion. So where's review? Isn't there a review? Oh, maybe not. Oh, waiting on review. There we go. Boom. And oh, this is still turned on. I should turn that off. Oh, interesting. It had lots of thoughts. Okay, let's actually see what Gemini had to say. Introduces a new constructor for UMAD with the primary goal is simplify the creation of UMAD instance by automatically calculating balance deletion rate based on the given addition rate. This balance rate derived from the formula blah blah blah, as suggested by research on UMAD, aims to maintain the average length of the genome during the evolutionary process. The pull request also updates several example programs. Blah blah blah. Let me grab this link. Copy URL. I probably will not read about that right this minute, but I can have a look at it later. Interesting. Okay, back to adds a new const, blah blah blah. Balance deletion late calculation. examples, change log. So that, I mean, these are pretty good summaries, better summaries than I write by a fair bit. So actually, I like that about them. Then code review. This is a useful addition. It's mostly straightforward. Couple of areas for improvement. One regarding input validation for the new constructor, and another concerning a small unrelated change in one of the example files. Also a minor note, the PR description appears to have an incomplete sentence, if one. Oh, did I really have a sentence? What? I think it read this before I'd finished it. And it did end with if one. So that's been changed. The new UMAD, new with balanced deletion constructor, should validate that the input addition rate is within the to prevent panics later during mutation. A panic bang with a clear message is recommended if the rate is invalid. PMD can be expressed in the very fun unit of nanometers per square root of nanometer. That is a weird unit. Nanometers per square root of nanometer. That is some strange stuff. So we don't actually check that those are legal probability rates anywhere in the UMAD or probably any of the other operators. I don't think we ever check any of that. Rand will panic. So we don't have to panic because Rand will do the panicking for us. If we checked, will Rand, can we provide a better error message than Rand could? Because if Rand won't know, so it wouldn't be a bad thing for us to check it. And it's in the constructor, so that only happens once, so it's not costing us anything meaningful. Yes, I did add something kind of random that isn't really part of this pull request. I don't know if we care. I can undo that. I kind of did it because I was dealing with, okay, you don't care. I'll leave it there. And then the PR description was a mess, yes. So they think that we should check the range. So they're suggesting basically that. Get added. And then this is, I'm going to just mark that as resolved. But this probably isn't a bad idea. And then we can make an issue about checking it elsewhere. I'll sort of do the UMAD version. Always good to have division by zero. Whee! So they recommend pasting in that code. Yes, good point. So contains is not const. Whoa, hello. Oh, that's just the panic. Oops. Panics. Blah. Does that make that go away? Use matches instead. So a range can match something? match. No. Oh. What? Okay, back up. Not matches addition rate. Huh. Okay. Not matches. Bang. Addition rate 0, 0. So that. And then does that bring const back in as an option? Oops. Oh, no. Because the panic doesn't let us do constant. Yeah. Only a panic in if-then statement. Try instead assert. Oh. Oh, sure. Assert makes sense. So we assert that it does match so we would do that instead of that. And what have I done? Right, so the assert gives us the positive, which is nice. Oh, I'm missing a close paren. That's my problem. No rules expected. Oh, I must have done it wrong. Assert. Does the message go first? No, the message goes second. Oh, I put the paren in the close. I'm missing a close paren there. I put it in the wrong place. That's my mistake. There we go. Okay. Yep. Awesome. Okay. So, we can go with this. Does panic support curly braces stuff? Or assert bang? Oh, and I could just put that directly in there. Yes, that's true. Oh, undo addition rate. And then skip that thing. Haha. Nice. And now I assume the const is still not going to work. No. Because oops, undo. No, No, that's undo. There we go. Bingo. That's nice. Ooh, I like that. And so debug assert would only check it in debug mode, whereas assert's going to check it even in release. And if this was in the sort of inner loop somewhere, I might care. But given that this is in a constructor, that's going to happen once, maybe, I don't think I'm going to worry about it. So I'd be inclined to leave this as just assert bang. But, okay, and then we need to turn this panics if actually, do we need if now that we're using assert, do you need a panic section? Yes. Good. Okay, that's interesting. So it's smart about that. A legal probability value. Range. Then this panics. Yeah, I agree with that. I just was curious to see like if it would give me the same complaint, and it did. So that's nice. Actually, I should say this. Start with this panics if the addition rate isn't a legal probability value. Smart Clippy. I mean, I have frequently been pretty amazed at how smart Clippy is. So I'm a big fan of Clippy. And that was one thing I definitely noticed in the Rust elective, is that once students sort of paid attention to Clippy, they were generally like super helped. They found Clippy very helpful. That was not a very good sentence. And yeah, absolutely. I think the dev tools make, because there is definitely an uphill battle in learning Rust, and the good quality dev tools make a big difference if people use them. I think that certainly one of the things that I struggled with, and I saw it in the students too, is you can get used to kind of ignoring a lot of what you get back from other systems because so much of it's just noise. Closure is terrible. I mean, just terrible about that. And Java's only a little better. And so getting used to the fact that the system's actually giving you useful feedback in a reasonable way and that you should read it and think about it takes some getting used to, but is a good thing. Okay, so cool. So that, I think, improves that universe. And just be paranoid, because I like being paranoid. We can run something to make sure stuff still works. Whee, it does. Yeah. Sigh. Okay. So I want to commit that. Change. Oops, I guess I have to stage that. That would be useful. Add, check, that addition rate. Yep, I hear you, Gaffa. Yeah, C++. I hadn't actually thought about C++ errors. It's been so long since I've written any C++ code. But yeah, the stuff you get out of C++ just is really can be quite terrifying. Is a legal probability value. In UMAD, new with balanced deletion. So this adds a check to that addition rate is a legal is in the range 0 ... equal 1. Yeah, bop, boop. We should do this on the other mutation and recombination operators, but we'll save that for another issue. Yeah, that's a good idea. I mean, there probably are a lot of places where we could assert things, both as a way of encoding assumptions, and making it more likely that if somebody fails to understand an assumption and breaks something later, it shows up as a boom. So okay, so then here is just a regular push. So I don't need to do anything fancy. Push. And so I will say that's a resolved conversation. And now it's contemplating its navel. And I probably want to add Justus as a reviewer. There we go. It got there. It just was slow. And I'll say that's ready for review. One thing I was surprised by is I kind of expected Gemini to like kick in and do another review kind of automatically. But it doesn't seem to do that. I suspect maybe if one... I don't know. I don't know what one would do to sort of cause it to re-review, but I think we've dealt with the things that it wants us to deal with, so I don't really need it to re-review and add noise. Merge is blocked. All kinds of things failed. Ooh, Rustock failed. What? Lifetime flowing from input to output with different syntax can be confusing. This is in bit string in EC linear. This has nothing to do with anything that we changed. So this is clearly a change in the universe that asks us to make, well, that's annoying. And it's after 12, so I need to wrap up. Maybe I'll try to deal with this later. But it looks like it's a simple fix. But that must be an update. Oh, and I wonder if... Do I have the Rust up check? I probably haven't updated my Rust in a while. So my stable is behind by 1. So we think that's the only thing that would need to be changed. So that's in bitstring rs. Bitstring. And it was line 66. So this iterator, it wants a thingamadoogie there. And that's it. Oh, and 70 of bitstring. Here, same thing. Wrong place. That lifetime in there. Okay. So maybe we can commit. Actually, cargo test just for fun. I don't know if there are any tests on any of this are going to matter for anything, but probably it doesn't look like it actually. But doodly doodly doo. So nothing broke. So what is the lifetime flows from input to output with different syntax can be confusing. So we're adding an anonymous lifetime to the iterator. Add. Well, I think that's one thing. If you turn on all the Clippy stuff, everybody ends up with lots of make Clippy happy commits. So be explicit. Make anonymous lifetime explicit in. This is in. Oops, what do I want? This is in. No, I wanted to be here. This is in bit string, right? Yes. In bit string iterators. Bit string iterators. Actually, is bit string? No, it's a little s. So an update to Clippy adds a warning that and suggests adding explicit anonymous lifetimes to the return types for bit string iter and bit string iter mute. Explicitly. Adding explicitly anonymous lifetimes. Update to Clippy adds a warning that lifetime blah 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 and suggests adding explicitly anonymous lifetimes to return types. This does that. Boom. Ba-dum, 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 ba-dum. Push. Go. Computer. Back. Oh, did I really? Explicitly. No, I think that I got all the explicitly. I think that's right. Reload the tab. So something succeeded. Oh, RustDoc succeeded. So that's good. Explicit. I think I have an L, don't I? Maybe not. I have an L here. Explicitly anonymous lifetimes. It's there. Oh, the title. Ah, you're right. Poop. Well, explicitly. I guess we can use our new push business again. Get push. Boom. And I want to be here. And now it starts all over again. Okay, so I should wrap up. we can do that while this is grinding away in the background. So what do we get? We get Saturday, which is the 14th of June from 2 to 4 p.m. More fun with Manum. Animations of EC concepts. And Sunday, 15 June. Oh, and I didn't do the CDT, UTC -5. Back to readmes for unhindered EC. Unless we decide we want to do something else. But I think we're close. I'm hopefully maybe one more session we get that done. But same issue in packages put. So we hit same. So the docs fail. Sigh. So cases mod. Cases. And what line it was on? 185. Oh. Weird. Probably also it would be here. Is that the only one? Yes. That'd be great. And so the idea is to just amend this. I guess it helps if I actually stage the file. A similar issue for case iter mute. Actually, cases iter mute, isn't it? Yes. Also resolves a similar issue for cases iter mute. And then we push again, because pushing is fun. And then that will blow up the world. It has to rebuild everything again. Blah, blah, blah. Okay. We wanted to make an issue quick about adding add assertions for, thank you, I appreciate it. Add assertions for probability parameters. There are numerous functions like mutation and recombination operators that take arguments that are intended to be probabilities, but we don't currently check that those values are legal. We should add assert bangs for those and document them in panics sections. Boom. And that would be documentation, and improvement, and probably pretty easy, and probably could use tests. Yeah, we probably should write tests for these things. You should also write tests to confirm that the assertions work correctly. And probably not the highest priority item in the world. Yeah, I'll just leave that undone. And then, okay, we'll quit there. Type, it is a task, I think. Okay. Voila, we have a new thingamadoogie. And this failed in which exciting way now? Pull request. Oh, okay, good. So the doc stuff worked. Stable failed though. Curious what happened there. Oh. We could have had const in two places. That's probably also a Clippy change. Okay, I'm not going to deal with that now. I need to go and do other stuff. Justus, if you get to it, great. If you don't, I'll try to get to it later. And I'll see everybody next week. Goodbye!